In previous videos, in the previous class, we spoke about multiplying and dividing negatives and positives. We are positive numbers or integers. We also spoke about adding and subtracting integers, which are negative and positive numbers. Now, this lesson will be on expanding brackets, right? Adding and subtracting of like terms and expand and simplify brackets. The objectives, you will understand how to add and subtract like terms, what expanding bracket means. You will also be able to expand brackets involving an expression with addition and subtraction. You will be able to expand and simplify brackets. Addition and subtraction of like terms. Like terms are multiple of the same quantity. For example, half y, 5y, 17y, all of those are multiples of y. So they are considered like terms. 1 over x, x squared, 3x squared, negative 5x squared are all multiples of x squared. So those are like terms. Look at this example. So 5x minus 13x plus 22x. All three terms are multiples of x and so are like terms. The expression can be simplified to 14x. Let's work it out for those who might be confused as to how they get the 14x. Okay? Now let's see. So remember, 5x minus 13x. What do you do? How do you solve that? Right? So 5x minus 13x. Right? So this is a positive 5 and a negative 13. So what do? You're going to subtract, and then the answer is going to take the sign of the larger number. Right? We're working on this side first. So it would be negative what? 5 from 13. 8, right? Negative 8x plus 22x, right? Now, this is a negative 8x and a positive 22. So what we're going to do, we're going to subtract and it take the sign of the larger number, which is a positive. So that's how the answer is 14x, which is positive 14x. Now look at this example. 5z plus 2x. These are not like terms. And so you can't add them. You can't add these terms. They're not like terms, right? So it remains the same. Now look at this example. 5a plus 2b minus 7a minus 9b, right? What I did here is to group the like terms. So if you can see, let me see what color should I use? Purple, I guess. Okay. So I group the 5a. That's blue. Okay, let's use blue. 5a and the 7a. These are like terms, right? And then the 2b and the 9b are like terms. So 5 is a positive and 7 is a negative. So what you're going to do, remember we're subtracting right here. You're going to subtract, right? So the answer is going to be, and well, after you subtract, you're going to take the sign of the larger number. So the answer is going to be what? Negative, because the larger number is a negative 7, negative 2a, right? Plus So 2b subtract 9b. Signs are different because this is a positive 2 and a negative 9b. So what we're going to do is subtract, and then it takes the sign of the larger number. So it won't be a positive right there. So let's erase this. So it's going to be negative, because it takes the sign of the larger number, 7b. So that's the answer. Okay. Okay, look at this example. Yes, it seems as if there is a lot going on right here, but don't be confused. Remember, every complex problem are made up of simple problems, right? So now, when you see a problem like this, the first thing you're gonna do is group like terms, and remember what like terms are. Now, if you see, I kind of try to color code the like terms. So we have 2x squared plus 11x squared. Those are like terms. And then you have the negative 7x and x. Those are like terms. So I put like terms together, right? So 2x squared plus 11x squared, that's 13x squared. See? You see that? And then negative 7x plus x. Remember, a negative and a positive. What you're going to do is subtract, and it takes the sign of the larger number. So that is why I said the answer is negative 6x, right? We're adding. Okay. If you're confused with the signs and stuff, look back on the previous video on the channel. Another example. We're doing like terms, right? No, don't be confused. It's in a fraction. In other videos, I'll go more in depth in fractions, because I know that a lot of persons are, they get nervous when they see fractions. Don't be nervous. This is just adding and subtracting right now, right? So the first thing I do when I see problems like this, I look at how I can make it simpler, you know. So I see the fraction, I'm like, okay, we're gonna add a fraction right now, because guess what? The fractions are the one with the like terms, right? The x's are the ones, are the like terms, right? So let's see. So we have a half x plus 3/4 x. So what I'm gonna do is to make the denominators be the same, right? The bottom numbers be the same. And in order to do that, I'm going to multiply the half x. I'm going to multiply the bottom and the top of this fraction by 2, right? So I'm going to multiply this by 2, and then I'm going to multiply the bottom by 2. So 1 times 2 is 2 over 4x plus 3 over 4x, right? And then now, because the denominators are the same, I can add the top numbers and put back the denominator. So the denominator is 4, then I'm going to add the top. So 3 plus 2 is 5. So 5x, right? Minus 2y. Now remember, the y and the x these are unlike terms, right? So you can't simplify no more. So that's the answer, right? If you have any problems with this one, put it in the comment section and I will clarify there. Okay? But I just make the denominators for the fraction be the same so that I could just add regularly. Okay? Okay, so like terms, group like terms, right? The 3a squared b minus 7a squared b, those are like terms. Minus 2b squared plus a squared, those are unlike terms. So what we're going to do is subtract the like term. So we're going to take 3 from the 7, right? So if you take 3 from 7, you leave 4, and then it's going to be a negative 4 because it takes the sign of the larger number. So it's negative 4a squared b minus, see, 2, going to put back the 2b squared plus a squared. Now look at it. The 4a squared b, 2b squared plus a squared, none of these are like terms. You see, they are different. 3 different terms, okay? So this is the solution. You can't go any further. You can't add anything. You can't subtract anything, okay? Now we have covered how to group like terms and unlike terms, right? Now we're going to talk about expanding brackets, removing the brackets, right? Now expanding brackets expand the numbers without changing their value. The brackets are then removed by multiplying with each term inside the bracket. Brackets are used to expand the numbers so that we can write the numbers in simplified form. Rule. While expanding brackets, the value outside the bracket is multiplied by each value inside the bracket, followed by addition and subtraction. While expanding brackets, the value outside of the bracket is multiplied by each value inside the bracket, followed by addition and subtraction. Expanding brackets. To expand brackets, multiply everything inside the bracket by what is outside of them, right? So you have 4a plus, the 4 is multiplying a plus 6, right? So 4 times the a, and then you're gonna do, that's 4a, 4 times a, the bracket means multiply. So 4 multiplied by a is 4a. And then 4 multiplied by 6 is what? 6 fours, 24. So remember, 4 times a, 4a, plus 4 times 6 is 24. Let's do another example. To expand brackets, you multiply everything inside the bracket by what is outside of them. 2 times, because 2t plus 4 is in a bracket, so the 2 will be multiplying everything that's in that bracket. So we got 2 times 2t. 2 times 2 is 4, so that's 4t. And then 2 times 4, so you're going to have 4t plus, there's a plus, then 2 times 4 is 8. Expanding brackets continues. Removing brackets mean multiplying out. For example, 5, you have the bracket 2 plus 4 equals 5 times the 2. Let me write it. Okay. So you have 5 times the 2, right? And then 5 times the 4. So it's 5 times 2 plus 5 times 4, right? So 5 times 2 or 2 times 5 is what? 10. 5 times 4 is 20. So 10 plus 20 is 30. In this simple example, we could alternatively give the same result, right? So 5, 2 plus 4 equals, if you add it, so we put back the 5, right? Then multiply by 6, because 4 plus 2 is 6. You still get 30. Get it? All right, look at it. 5 times 2 plus 5 times 4. You get the same answer. Okay? That's the distributive law. All right? Look at this using letters. A is multiplying what's in the bracket B plus C. So A times B plus A times C. If there's a subtraction, A times B minus A times C. As we have noted above, if you insert numbers instead of letters into this expression, you will see that both left and right hand sides are equivalent, equal. For example, 4, open bracket, 3 plus 5 has the same value as 4 times 3 plus 4 times 5. That is 32, right? Because look, if you add what's in the bracket, so 5, 6, 7, 8. So 4 times 8 is 32. And if you expand the bracket, 4 times 3 plus 4 times 5, you still get 32. And the same applies to 7, open bracket, 8, subtract 3, to have the same value as 7 times 8 minus 7 times 3. That is 35. Okay? In the expression 9, open bracket, 2 plus y, close bracket, the 9 must multiply both terms in the bracket. So it's 9 times 2 plus 9 times y equals what? 18 plus 9y. Because 9 2 is 18, right? Plus 9y. And what we can't do, we can't go any further because those are unlike terms. So recall that 9 times 2y means 9 times 2 times y. And that when multiplying numbers together, the presence of brackets are irrelevant. Right? So it is important to distinguish between the role of the factor 9 in the two expressions. So 9, open bracket 2 plus y, and 9 2y. You see the distinction? If you don't see the distinction, leave a comment. Okay, now we're going to remove the bracket from negative 3, open bracket 5x minus z. The number negative 3 must multiply both the 5x and the z. Remember, you got to multiply everything in the bracket. So, negative 3x, no. So, it's negative 3 times 5x minus negative 3 times z equals, remember, negative, now we're multiplying integers now, right? So negative times positive. Remember, if the language is different, it's going to be negative. So 3 times 5 is negative 15x. Minus, minus. Both minus are together, right? You see them right there. They're together. Let me see right here. Ooh, right there. So it becomes a positive. So plus 3z. And that's the answer. So let's do this now. 6x is going to multiply each number in the bracket. So 6x times 3x is 18x squared. Right? That's supposed to be a square right there. So it's 18x squared. Subtract, because why it's become a subtraction, because it's negative times a positive. The languages are not the same, so it's got to be negative. So it's negative 12x y. See? Multiply each number in the bracket by 6x. These are unlike terms, so that's the furthest it can go. Let's look at this example. Remove the brackets from negative 3x minus 1. Although the 1 is unwritten, right? That would be in front of the bracket right there. The minus sign outside the bracket stands for negative 1. We must therefore consider the expression as negative 1 times 3x plus 1. So all those expressions in the brackets are going to be multiplied by negative 1, right? So it's negative 1 times 3x. Negative and positive give negative. Language don't work. So negative, languages are different. So it's negative. So negative 3x, right? Negative 1 plus 1, negative 1. So that's the answer. Another example. Remove the brackets from negative 5x minus 3y. Same thing. So it's negative 1 times 5x is negative 5x. But look at this. Negative 1 times negative 3y. So the signs, the languages are the same. The signs are the same. So it's going to be plus 3y. And that's the answer. Unlike terms, they can't do nothing more with it. Let's remove this bracket. Easy, easy. M squared, M times M is M squared minus Mn, right? Do we get that? Look at this example, 5x minus 3x plus 1. The 3x plus 1 is in a bracket. Remember, there's no 1 in front of the bracket right there, but you can, it's safe to say that there is a 1, right? So what's in the bracket should be multiplied by negative 1. So we're going to put back the 5x, subtract, we're going to expand the bracket, right? Now, negative 1 times 3x is negative 3x, negative 1 plus negative 1 times 1 is negative 1, right? So now these are like terms, 5x minus 3x. You're going to subtract and take the sign of the larger number, which is a positive. So that's why this answer is 2x subtract 1. These are all equivalent. Minus x minus 1 over 4, minus open bracket x plus 1 over 4, and x minus x plus 1 over 4 are all equivalent expressions. A negative quantity divided by a positive quantity will be negative. Remember, I tell you in previous slides, our previous lessons, if the languages are different, there's a language barrier, so the result's going to be negative, right? If the languages are the same, that means if there's positive, the signs are both positive, or the signs are negative, the answer is going to be positive. That's with multiplication and division, okay? Now, going to remove the brackets, 2 brackets now, right? So remember, they must multiply each other, right? Everything in one bracket must multiply the other, everything in the other bracket, right? So one way we can do that is what? We can multiply the 3 plus x times the 2, and then the 3 plus x times the y. You see that? So you're multiplying everything in the first with the second. And then, 3 times 2 plus 2 times x plus 3 times y plus x times y, right? Then you simplify 6 plus 2x plus 3y plus x. And it can even go a little simpler because you have like terms, which is 2x and the x. So it's 6 plus 3x plus 3y. Okay, let's remove this bracket as well. So let me write it, even though it's typed there, but let me write. So it's 3x plus 4. We're going to multiply that by x. This is from the dot, right? Plus 3x plus 4 again. Close the bracket. And we're going to multiply that by the 2. Right? Now we're going to do 3x times the x is 3x squared. You're going to multiply the x by the 4, 4x, right? Plus 3x times 2, 6x, 4x times 2, 8. Right? And then they group like terms together and add. Right? There's no subtraction in this one. Now with this one, you're going to remove the bracket a plus b squared and simplify your results, right? When a quantity is squared by itself, where it's squared, it is multiplied by itself. Therefore, a plus b squared is the same as a plus b times a plus b. And then you do the expansion, right? So you can do a plus b times by a, right? Plus a plus b times by b. Because you're multiplying the first bracket by everything in the second bracket. and then you just simplify. So it's a squared plus b squared plus ab, and group like terms. Okay. The same applies to this example. X plus 7, x plus 3. So you're going to multiply what's in the first bracket by everything in the second. So it's x plus 3 times x. No, x plus 7 times x. And then you have x plus 7 times 3. Right? So when you do that, you expand the bracket, you're going to get the solution for there. Look at B. X plus 3 times x, and x plus 3 times negative 2. Right? Work it out and see if you get the answer. Pay attention to this one. Look at the difference between x plus 3 in bracket times x plus 2. So both bracket multiplying each other. And then you have x plus 3. It's not in bracket, but you have x plus 2 in bracket. Now, in the first expression, you're going to expand the bracket, right? So x plus 3 is going to multiply by x, and x plus 3 is going to multiply by 2. Now, in the second expression, where we have 3 times x plus 3 times x plus 2, the only thing that is being multiplied is by the only value that you're multiplying, or I should say, the bracket is what's in the bracket is being multiplied by 3 only. That's what I should say, right? So it's x plus 3x plus 3 times 2, right? If you don't understand, leave a comment in the comment section. This is another example. The rules remain the same. Everything in one bracket should be multiplied by the other bracket, right? So it's x squared times s, 2s times s plus 4s times s, and then do s squared times 3 plus 3s times 3 plus 4 times 3. Okay, you group like terms and then you do your computation. Right, let's spot the mistakes, right? Look at the mistake. So you're going to multiply what's outside the bracket by q plus 6 for number 1. So it's 3q plus, not 6. It's 3 times 6, right? So that's the mistake right there. You have the same, it's the same thing throughout. Just to show you that you got to multiply everything in the bracket by the operation, right? So 9 got to be multiplied by 4. You got to multiply the first term and the second term. Negative times positive. 6 times negative 5 is a negative. Two different languages. Remember? 8 times negative 3. So first of all, 8w. It should be 8w, right? 8w subtract, right? So that's wrong. And then this, cool. Questions, leave it in the comment section. Now, 4 times y plus 2. What answer is that? A, B, C, or D? Yes, it is C. 4y plus 4 2 is 8. Let's do that one. 4y, what's the answer? 4y minus 4 5s, 20. Get this one. Nice. Let's go. Lovely. All right. Yes. Okay. All right. You're getting it. We're getting there. Look at you. Understand. These are just some examples. Do it on your own. And same thing. 3n plus 3. Let's get it. Let's get it. 5. Yep. 70. Yep. 18. Nice. Negative and positive. Nice. Okay. Look at this one. Easy, right? Cause you want to find what you multiply by 2 to get 6 to get 12, right? To get this. 6 to 12. Easy. Look at this. You want to know what you multiply by to get 2. Something times 1 to get 2. Look at that. Easy. Look at that. Nice. Oh, you see fraction, you get nervous, but it's alpha 1. Alpha 2 is 1, right? Yep. So what? But they didn't ask for that anyway. So it's 2 2 4. Yeah. 3 5 15. All right, look at that. Don't get nervous now. Let's go. 5. Half of 10 is 5, yeah? Look at that. Oh, you know which one it is. What times 4 give you 36? Bam. Bam. Now, if you have any questions, please go in the comments. You need to subscribe to the channel so that you can get updates whenever new videos are posted. New videos are posted every week, and it's geared towards the ASVAB math portion. There will be other sections as well, but the main focus is on math because that's what goes towards the AFQT. Okay.